Hi, so in this video we're going to start talking about Pythagoras. This is going to be a series of videos on the YouTube channel, and it's a particular playlist which I'm going to call Pythagoras, or you can have a look at mathsrap.co.uk, and there will also be a posting on Pythagoras on that particular website. I'm going to start with looking at the theory, or looking at one of the proofs of Pythagoras' theory. Most people are familiar with the idea that c squared equals a squared plus b squared, and that refers to a right angle triangle. So we've got something like this. It has to be a right angle triangle, and the hypotenuse, which is the longest side along here, they're normally called c. The adjacent will be a, and the opposite will be b, or these two other sides will be a and b. And Pythagoras says that if you square this side and you square this side, if you add those two together, you get this side squared. So probably the easiest way of calculating it, and you can use a calculator to try these sorts of things, where if you use what they call a 3, 4, 5 triangle, so you say that that's 3, and that's 4 centimetres, and this is 5 centimetres, well, the numbers do work out, because a squared, which is 3 squared, plus b squared, which is 4 squared, equals 5 squared, because 3 squared is 3 times 3, which is 9, and 4 squared is 4 times 4, which is 16. And if you add 9 plus 16 together, you get 25, which is 5 squared. There are quite a lot of examples on mathsrap.co.uk, and you can download a quick test and you can have a go at some of these problems for yourself. And in the next video I'm going to talk specifically about a couple of these problems that will occur on exam papers. However, for the purposes of this particular video, I just wanted to look at this whole idea of Pythagoras and look at one of about 200 proofs that come out for Pythagoras' theorem. There's quite a lot of them, but perhaps one of the better known ones is to use right angle triangles. I'm going to do my best to draw this up on the board as best I can. I can't put it into the description box underneath the YouTube video, but I will put it onto the MathsRap site so you can have a look at it there. And what we do is we say, well, actually, if you imagine that we're going to tip one of these squares on its side, so the hypotenuse is like that, and we've got a right angle there. Well, if we then take that and we just put the normal letter designation, so A for the small side, B for the long side, and C for the hypotenuse, we're going to now build up a picture of a square. So the way that we would do that is that we would take another right angle triangle which is exactly the same size, lay the hypotenuse along there and create a shape like that, which also has side A, side B and side C, which is the hypotenuse. I hope you can see this okay on the video. The next thing we're going to do is we're going to again lay another triangle along the top here which is exactly the same size. I hope that's come out okay. My drawing is probably a little bit wobbly. It's looking a bit wobbly from where I am, but it'll give you some idea. Okay, so the shorter side there is A, and the long side here is B, and the hypotenuse is C. And then finally I'm going to put another triangle with a hypotenuse of C and sides of A and B. And all of these triangles are right angle triangles. So what we've done is we've created a shape where the middle bit of the shape is a square, because all of these sides are equal. Well, the question is, how do you find out the area of that square? Because the area of that square is c squared. Well, that's perfectly true, but perhaps another way of doing it would be to take the outside square, so the larger square, take away the area of the triangles, and what you're left with is the area of the square in the middle. And if the two things are equal, then it means that you've proven that c squared, which is c times c, equals a squared plus b squared. Okay, so what I mean by that is, let's look at the square itself. So the bit in the middle, so this little bit in the middle, so the square itself, I'm going to write this here, the square equals c squared. So that's c times c to make this piece in the middle. Okay, so let's look now at the area of the outside square, so the larger square. So the large square equals two of these sides, or this side multiplied by this side. So what we've got is a plus b multiplied by a plus b. And that's actually the area of the larger square. Okay. Then what I'm going to do is I'm going to look at the area of each of the triangles, and I'm going to multiply each of the triangles by 4, because we've got 4 triangles in total. Okay, so if we look at the area of a triangle, what we've got is a half width times height. So let's look at that as a formula. We've got half width times height. Okay, well, the area of the triangle is A, which is the width, and B, which is the height. So I'm going to rewrite that as a half A times B. And then, because there's 4 of them, I'm going to multiply that by 4. Okay. So in other words, what we've achieved is that we've got ourselves a way of calculating the area of the larger square, a way of calculating the area of the triangles, and if we take one away, or take that away from that, then we should end up with the area of the centre piece. Okay, so let's do that. So let's look firstly at the area of the large square. So I'm going to write this out on the board here as large square minus triangles. Okay. And what we'll do is we'll work down the board. Okay, so large square is A plus B multiplied by A plus B. And the area of the triangles we've said is this, which is 4 times a half A times B. So that's going to equal 2AB, because we've got A times B, which is AB, a half times AB, and if we've got 4 lots of a half, then that equals 2. So 4 times a half is 2 AB. So the area of the triangles in total is going to be 2AB. Okay, so we use a little bit of multiplication out of the brackets here. So if we do that, we've got A times A, which is A squared, A times B, which is positive AB, B times A, which is positive AB again, and then we've got B times B, which is B squared. So that's multiplying out those brackets. And if you have a look at some of the other videos on the YouTube channel, have a look at the factorisation type videos or expanding brackets. I think there's a playlist on those that you can have a look at. Or if you go to mathswrap.co.uk, you'll be able to see how I've done that. But it's basically using a technique which a lot of people call FOIL, where I'm multiplying each of these terms by each other. So I will end up with A squared plus AB plus AB plus B squared. So I'm going to tidy that up, and I'm going to end up with A squared plus 2AB plus B squared. So in other words, that formula will allow me to calculate the area of this large square. So I could have any value of A and any value of B, and providing I've got all of the four triangles exactly equal, then I'll be able to make out, I'll be able to calculate the area of the large square. Okay, so the area of the triangles we said is minus 2AB, because we're taking the area of the triangles away from the large square. Well, if we do that, we've got two terms that we can cancel out, because we've got positive 2AB and negative 2AB. So if we cancel those two terms out, we're left with A squared plus B squared. And that A squared plus B squared is the area of the square in the middle. So the smaller square in the middle, which we've already said is C squared. So A squared plus B squared must equal the square, which equals C squared. So A squared plus B squared equals C squared. That was fairly intense, and I appreciate that that probably took a little while to work through. Please do try it for yourself. Do have a look at the post on MathsWrap. I hope you've found it useful to you. It doesn't particularly appear in GCSE or other types of exam papers, but it's useful to know as a little bit of background as to one of the ways in which we can prove Pythagoras theory. Please do subscribe to the YouTube channel, have a look at MathsWrap, add a comment below and I will come back to you. And if you look at the playlist on the YouTube channel, there are some practical problems and practical exam questions that I'm going to address using the same sort of method. Look forward to seeing you inside the next video.